Hello everyone, today let's solve remove duplicates from sorted list. So given a sorted linked list, we have to delete all the duplicates. So let's see how we approach this problem. So first, we will create a dummy node, okay, and then assign the head to the dummy next, so it becomes legs. And the purpose of dummy node is in order to not lose track of the head. And then we also have to create two pointers. First is previous, another one is current. Okay. And let's see our logic. So as long as current is not nil, and then we have to also check whether or not the next is not nil. Okay, because we have to compare with the next node. Okay. As long as both not nil, so we compare whether or not the value is the same. If it is the same, we should move the current node to the next node, which means we delete the duplicate one. Okay, and if we no longer satisfy this condition, means that we already remove all the duplicates. So we have to assign the previous node next, right? We have to move the pointer. The previous has to point to the current node, which means that we point to the only node, and then we have to move the current node to the next node, like continue, because we have to follow the logic again. So we have to move the current node to the next and move the previous to the next. So I will show you the every step here, so you have better understand what I mean here. So let's start it. So this is the initial phrase. Okay, we assigned dummy node to previous and assign the head to the current. So current is not nil, and the next is not nil. So we compare the value. It's the same. So we remove the previous one. Remove this one. Okay, and continue. Right, and this time current is not nil, and the next is not nil. So compare the value. Right, it's the same. So we keep moving. So it means that we already removed the first and second node. Third time, see the current is not nil, the next is not nil. Compare. It's not the same. It means that we already removed all the duplicates. One. We already removed all the duplicates. One. So it means that we have to start changing the pointer, right? So first thing, we have to point, right? We have to assign one to the dummy next, right here. Previous points to current. Means that dummy next have to point to what here, and then we already remove here. Remove this. Move current to current next means that because we have to continue the logic, so move current to the next, and then we have to move previous to next. This means that previous equals to previous next. So previous move to here, and then we continue follow this logic. Current is not nil, and next is not nil, and they are not the same, right? So we have to change the pointer, right? So previous next, it will has to point to the current, and then we move current to next, previous to the next one, and here current is not nil, next is not nil, but the value is the same, so we have to move current. This logic, move current to the next node. Okay, it means that we already remove the 3 here. So we have to keep following, right? As long as current next is not nil, but right now it's nil, so it means that we no longer satisfy this condition. So we have to change the pointer. We have to point the previous node next to the current node, right? And then move our current node to the next, and move our previous node to the next. And we no longer satisfy this condition. Current is not nil. So we finish the logic, and we also fulfill the requirement that we remove all the duplicate nodes. So then we just have to return dummy.next, which means this node. So that's the overall logic. So let's see how we implement this logic in Go. Okay. Okay, so first check the boundary condition. So if head is equal to nil, we just return the head. Nothing to do, right? Okay, so and the first thing we need three things. First, dummy node. Dummy node is a list node. Okay, and then we need the previous node, previous, and the next, and the current. Previous we assign dummy, and the current we just assign head. So as long as our current is not nil, we have to do the following things. As long as the current next is not nil, because we have to compare the value. Okay, so if both conditions satisfy, it means that both current and next is not nil, right? So are not nil. So we compare the value current val. If they are the same, current next val, they are the same. We have to remove the duplicate one, right? So current equal to current next means that we remove the current one and move to the next. Okay, and if we no longer satisfy condition, we have to change the pointer. So first thing, we have to assign current to previous next. Okay, and then we start moving current to the next node, current next, and the previous to the next node. Okay, previous has to become previous next, and we continue this logic again. Okay, and that's it. So the time complexity for this logic is O(n) since we loop through all the nodes, and the space complexity is O(1). We don't use any extra space. Oh, here I forgot to. In the end, we need to return dummy next. So dummy next is the head we have to return, and that's it. And submit it. Yeah, and that's it. Thank you for watching.